You've been traveling outward for longer than you can measure. The stars have been gone for a while now, and you just realized the darkness ahead of you and the darkness behind you are the same thing. Let's back up. You left Earth at impossible speed. For a while it was beautiful. The sun shrinking to a dot, the Milky Way unfurling like a pale ribbon behind you. Then the ribbon shrank. 100,000 light years out, the last individual stars vanished. Not dimmed, vanished. Like someone turned them off one by one and forgot to tell you. Now you're in intergalactic space. And intergalactic space has a personality. It's not just empty, it's aggressively empty. 1 hydrogen atom per cubic meter. A single breath of air back home has 10 trillion more molecules than this. You could fly for 1 million years and never hit anything. Your eyes are useless here. The only radiation flooding this space is the cosmic microwave background. Ancient light stretched so far, it became invisible. Microwaves. You're swimming in it, and you can't see a thing. The temperature outside is 2.725 Kelvin, 2.5 degrees above the coldest anything can ever be. No sound, because vacuum. No warmth on your skin, because there's nothing to conduct it. Just you. Drifting, in a silence so total it doesn't even have texture. You came out here expecting to find something at the edge. Instead, things are being taken away. And the emptiest part? You haven't even reached it yet. Ahead of you is the Bota's void, 330 million light years across. Inside it, roughly 60 galaxies. There should be 2,000. Robert Kirshner found it in 1981, and the best description of it came from astronomer Greg Aldering, who said if the Milky Way had been in the center of the Bota's void, we wouldn't have known other galaxies existed until the 1960s. Imagine building your entire understanding of reality. And it's wrong. Not because you're stupid. Because the universe hid the answers behind 300 million light years of nothing. You're crossing that nothing right now. Every direction black. For a span that would take light itself hundreds of millions of years to cross, there is just this. And here's the part that should bother you. 80% of the universe's volume is void. The cosmic web, that beautiful structure of galaxy clusters and filaments you've seen in documentations, it's mostly holes. We live on the foam. The emptiness isn't the exception. It's the default. You're not passing through a weird patch. You're seeing what the universe actually looks like when it's being honest. We even live inside a void right now. The KBC void. 2 billion light years across. You were born in one of these and never noticed. So you keep going. Because the edge has to be out there somewhere, right? There has to be a wall, a boundary, a line where the universe stops, and something else starts. There isn't. But there are 3 invisible boundaries nested inside each other, and each one is worse than the last. The first is the particle horizon, 46.5 billion light years away. That's the farthest anything has ever sent light that's reached us. It defines the observable universe 93 billion light years across. And yes, that's bigger than the universe is old, because space itself has been stretching the whole time. The light left its source 13.8 billion years ago, but the spot it came from has been riding the expansion ever since. It's now 3 times farther than it was when it sent that signal. The second boundary is closer. Much closer. 16 billion light years. This is the cosmic event horizon. And this is the one that matters. Anything beyond this line right now will never reach you. Not in 1 billion years. Not in infinite time. The space between you and it is expanding faster than light can cross it. It's not a wall. It's a sentence. Everything past it is gone. Permanently. You're approaching it now. Nothing changes around you. No shimmer, no line, no sound. But behind you, home, the light is starting to stretch. The colors are reddening. Things are getting dimmer. Not because they're dying, because the space between you and them is growing faster than their light can keep up. You expected one edge. There are 3. And the scariest one was the closest. But here's what gets me. You're staring into what you think is darkness. It isn't. If your eyes could see microwaves, this moment would look completely different. You'd be surrounded, not by black, but by a dim, ancient glow coming from every direction equally. The cosmic microwave background. The afterimage of creation itself. 380,000 years after the Big Bang, the universe was a 3,000-degree plasma. Everything was on fire. Then it cooled just enough for atoms to form, and light escaped for the first time. That light has been traveling ever since. Expansion stretched it from a dull red glow into microwaves, red shifted by a factor of 1,089. But it's still here. It's still arriving. Physicist Charles Lineweaver called it the surface of last screaming. Imagine an infinite field of people who all stop screaming at the same instant. You'd always hear screams coming from a shell around you, farther and farther away, because sound takes time to travel. The CMB is that scream. The universe's birth cry, still washing over you, always arriving from a little farther out. When the Kobe satellite mapped it in 1992, George Smoot looked at the data and said, "If you're religious, it's like looking at the face of God. You're inside the fireball. You always have been. The darkness wasn't empty, it was hiding the oldest light in existence, wrapped around you like a cocoon you couldn't see. And that light told us something uncomfortable. When the Planck satellite measured it in 2009 with the sharpest resolution yet, the numbers came back. 68% dark energy, 27% dark matter, 5% ordinary matter. Everything you've ever touched, seen, loved, or been, 5% of what exists. Now turn around. Try to go home. This is where the video stops being about what's out there and becomes about what's happening to you. The cosmic event horizon isn't just ahead. It's behind you now. While you were traveling outward, the expansion didn't pause. Earth, the Sun, the Milky Way, they've been receding. And if you've come far enough, they've crossed the threshold. The light from home is stretching, reddening, dimming. Not because anything was destroyed, because the space between you and everything you know is growing faster than information can cross it. Every second, more of the universe slides past the event horizon. Galaxies don't explode, they don't collapse. They just redshift into silence. One by one, they fade to black. Not gone, just unreachable. Informationally erased. You look back. The spot where home was is dark. Not because it's far away, because the light will never arrive. And this isn't hypothetical. This is the future. In 150 billion years, every galaxy outside our local group will have vanished past the event horizon. A civilization born then would see one galaxy in an endless void. No cosmic microwave background. Too faint, too redshifted. No evidence of the Big Bang. No evidence of expansion. They would build a completely wrong cosmology from scratch and have no way to know it was wrong. The window of knowledge we're sitting in right now, where we can still see the CMB, still count distant galaxies, still piece the story together, it might be temporary and unrepeatable. You are currently floating in the most information-rich era the universe will ever have. It's all downhill from here, unless the rules change. For 25 years, we assumed dark energy was a cosmological constant, fixed, predictable. The universe would expand forever, cool forever, die the slowest death imaginable. The big freeze. Stars burn out. Black holes evaporate. Entropy wins. That was the ending. Then DESI, the Dark Energy Spectroscopic Instrument, 5,000 robotic fibers on a telescope in Arizona, mapped over 40 million objects and said, actually, we're not sure anymore. Their first data release in April of 2024 hinted that dark energy might be weakening. Their second, March 2025, pushed the confidence to 4.2 sigma. That's 99.995%. Not proof, 5 sigma is the threshold for discovery in physics. But strong enough that Will Percival, one of the lead scientists, said the simplest explanation for what we see is shifting. If dark energy is weakening, the expansion might slow down, might stop, might reverse. The universe doesn't freeze. It collapses back into itself. If it's strengthening instead, you get the big rip. Space expands so violently it tears apart galaxies, then solar systems, then planets, then atoms. Everything shredded from the largest structures down to the smallest. The force that trapped you out here might not even be permanent, but every alternative is also terrifying. The Vera Rubin Observatory captures first light this year. The Roman Space Telescope launches in 2027. We might have answers within a decade, or we might find out the question was bigger than we thought. You're still floating out here. You remember everything: your name, your street, the way morning light came through your window. But here's a thought that won't leave you alone. If the universe lasts long enough, and we're talking timescales so large the number has an exponent inside its own exponent, 10 to the 10 to the 50th power years, random quantum fluctuations would eventually assemble a conscious brain in the void. Fully formed, complete with memories. Memories of a life it never lived, a planet it never visited, a morning light that never existed. These are called Boltzmann brains. And in an eternal universe, they'd outnumber every real observer who ever lived. Physicist Brian Greene put it this way: I am confident that I am not a Boltzmann brain. However, we want our theories to similarly concur, but so far it has proved surprisingly difficult. You're floating in the dark. You remember your whole life, but how would you know if those memories were real? You stop moving, you look around, same blackness in every direction. There was never a wall out here. There was never a line or a gate or a sign that says you are now leaving the universe. The edge isn't ahead of you. It was never ahead of you. Here's the thing. Astronomer Heinrich Olbers asked a question in 1823. If the universe is infinite and full of stars, why is the sky dark at night? The answer is that light from the farthest reaches hasn't had time to reach us. The dark sky at night is the edge. You see it every time you look up. The observable universe is centered on whoever's observing. Move. And it moves with you. There is no privileged view. Everyone is at the center of their own horizon. And no matter how far you travel, you will always be surrounded by a sphere of everything you can see and an infinity of everything you can't. The edge of the universe isn't a place. It's a question you can never answer, receding from you at the speed of light. You've been staring at it your whole life. You just called it the night sky.